Hey everyone, Cody from Mactelecom Networks. It's that time of year again where I do a walkthrough of a full UniFi network build for the year 2026. We do this yearly, and every year there are a ton of new features, and the GUI interface for the UniFi network application typically looks a little bit different. Now we're going to go over creating Wi-Fi networks, creating VLANs, doing port security, also doing our zone-based firewalls, and I'll also show you the physical connections within my rack. This video is going to be very long, so there will be chapters down below. So if you don't care about things like adopting devices, you could just jump straight forward to something like firewall rules. In this video, I'll be doing a setup what I would do for my basic install at maybe a business, but you could still use the same concepts for your home network. If you don't want to do any of this yourself, I do offer remote consultations for anywhere in the world. We also do physical installations of UniFi access, network talk, and anything UniFi related, as well as structured cabling. So if you want to hire me, visit my website at mactelecomnetworks.com. This first section, we're just going to go over quickly, as you could do the research yourself, but it's going to be about what gear to buy and what suits you the best. The nice thing about the Ubiquiti website is they have a compare feature. So you could look through all of their cloud gateways, switches, Wi-Fi, and see what would be perfect for you. So say we're trying to build out a business and we don't know if we need an EFG or if we need a Dream Machine Pro Max. Well, I could click over or hover over the Enterprise Fortress Gateway and click on compare. Then I'm going to go over to the Dream Machine Pro Max. I'll click compare as well, and then at the bottom, we'll do the comparison. Over on compare, we could see the tech specs for both of the EFG and the Dream Machine Pro Max. We could also click on unique specs only. So this is going to show us that the EFG only runs UniFi network. It doesn't run protect, access, talk, or connect. So if you need any of those applications, you either want to go with the Dream Machine Pro Max or you're going to have to host them somewhere else. We could also see the differences in managed UniFi devices. The EFG does 500 plus, whereas the Dream Machine Pro Max only does 200. We could also see the difference in simultaneous users connected, which the EFG does 5,000 and the Dream Machine Pro Max does 2,000. So this is a great starting point to see which equipment that you need. The next thing is UniFi Design Center, which is completely free, and you actually don't even need to be signed into account to start it off. I'm not signed into account right now, and you could see that it already built a rack for me, which cost about $200,000 US. But you could try a demo project. With this demo project, it brought all the gear over that was about that $200,000 worth of gear, and you could see it on the right-hand side. So we have an E7 access point where we could grab it, and then we could place it somewhere on the map. This is going to give you a visual representation of what the Wi-Fi coverage would be for your building. I do have a full video on UniFi Design Center and how to use it, and I'll link that down below. But this is a great starting step for free, again, just to design either your business or your house network. Before we go down to my network rack and do the physical connections, let's take a look at the topology of what we'll be using in the networks and the VLANs. At the top, I have my Dream Machine Pro Max, and I do have two different ISPs that will be plugging into this. Below that, I have a Pro Aggregation switch, and then I have an ECS 48 PoE. For our access points, I'm going to be using an E7 access point and one of the wall access points, which is the XG. I have a couple other US, I think these are flex switches, and that is for my cameras. I have a PDU, I have a NAS, which is the 2-bay, I have an RPS, and then we will have a UMBR on this as well. The networks and VLANs that we're going to use, we have our default network at 192.168.10.1. That will be for all of our UniFi equipment. Then we have our guest network at 192.168.20.1 on VLAN 20, which will also have a Wi-Fi network. We have IoT on 30.1, which is VLAN 30. They will also have Wi-Fi. We have my camera network, 192.168.40.1, VLAN 40. That won't have Wi-Fi, but then we will have a SAP network on 192.168.50.1, and this will be on VLAN 50 with a Wi-Fi network. Some people may ask, why are you using the 192 address space? Well, it doesn't really matter as long as you're using a private address space. I was going to go with 10, but in my previous videos or the full network builds, we've always used the 192 address space, so that's why I'm doing it. The next thing I need to do, I need to reset all of my gear, and then we're going to go downstairs and we're going to get this physically connected together. While the UDM is booting up, we just factory reset this device. We're going to get our cabling done. You can see under the UDM Pro Max that I have this patch panel. These cables, they go through all of my walls inside my house, and they're going to connect to things like our security cameras, our access points, and then some data cables maybe behind my TV and in my office. They'll also connect to IoT devices like my Philips Hue bridge. So what we're going to want to do, we need to get some Cat6 cables, which I have the Ubiquiti Ether lighting. These are the braided cables, and we need to plug those into the switch. I don't have any of this labeled. You probably want to do that just so you know where things are, but I switch it around so much. But the ports at the end, these are my ISP ports. So we have ISP1 and then we have ISP2. So I'm just going to grab these cables and I'm going to start plugging them in from the patch panel into my ECS switch. Now we have all of the patch panel cables plugged into our switch, and we also have our internet uplinks. You'd see that I have this brush panel below, and there are some Ethernet cables sticking out of it. This would be things for like my NAS. Maybe I do have a Philips Hue down there. I have the AI key, so we need to get these plugged in as well. All right, and all of those cables are now plugged in. If we look back at my network topology, you would see that the UDM Pro Max was directly connecting down to this switch below, which was my aggregation switch. So we're going to grab a DAC cable and we're going to plug it in. So I'm just going to insert it into the UDM Pro Max, and these can only go in one way. So if you push it in and it doesn't go in all the way, just flip it around. Now it's in the UDM Pro Max. I'm going to go down to the Pro aggregation switch. From the ECS switch, we're going to be plugging into the Pro aggregation, and I do have this smaller DAC cable, and it's going to be going at 25 gigabit per second because that's the port speed on the ECS switch as well as this Pro aggregation switch. So I'll click them both in, and now they should have some sort of connectivity. We would see on the screen here, or you may not be able to, but it is saying ready for setup. The easiest way to get these set up right away is by going into our UniFi network application on our phone. So that's what I'm going to do, and you'll be seeing a screen recording here. I've now launched the UniFi network application, and you can see it picked up Dream Machine Pro Max, and we're going to press setup. It's now connecting to the Pro Max, and it's asking to give it a name. I'll call it Mactelecom PM for Pro Max, and we'll press next. Now it's doing a speed test, and you can see I'm getting about 1900 megabits per second download, and then we'll see the upload here in a second, which I'm getting 50, which is pretty standard for our coax connection. I do have a fiber connection that's plugged into WAN 2 that does go 3 gig by 3 gig. The next thing it's saying is setting up UniFi OS. So now what we need to do, we need to get all of these devices adopted. So my access points as well as my switches. So I'm going to go upstairs and we'll do that on the computer. We're back at the computer, and you can see that we have a bunch of devices that need to be adopted within our UniFi network application. You'd see the IP address is 192.168.1.1 or 1.x/24. What we want for our default network is 192.168.10.x/24. So we're going to change that first before we adopt these devices so that they'll get the correct IP addresses. So I'm going to go over to the settings wheel in the left-hand corner. And from here, I'm going to click on networks. On networks, we could see our default network, and we're going to click that off. Now we can see we have our IPv4 and it has auto scale turned on. I always turn auto scale off, and we're going to have this go at 192.168.10.1, and we're going to apply those changes. Once those changes are applied, all those devices should get a new IP address from the subnet. The new subnet has been applied, but we could see a couple devices are still stuck on that one. So what I'm going to do, I'm going to adopt the USW Pro aggregation switch first. Once we adopt these devices into our network controller, that will give us the ability to configure these devices. If they're not inside a UniFi network application, you can't do any configuration with them. They would just act as a dumb switch. So I'm going to go ahead and I'm going to click on this, and we're going to click to adopt the USW aggregation. These APs, they did switch over, but the ECS48 haven't yet. So let's just do the aggregation. I'll click adopt, and that's going to adopt it. If there's any updates, it will also update it. The Pro aggregation is now adopted. We need to get the rest of these devices adopted into our network. So I'm just going to go to the left-hand corner, and we're going to adopt them all. This will take a few minutes to do. All of our devices are now adopted into the UniFi network application, and they all have an IP from 192.168.10. You'd see they're also all up to date. The next thing that we want to make sure is up to date is our UniFi OS as well as our UniFi network application. So we'll click in the left-hand corner on the settings wheel. Then we click on the control plane. You can see that the network is the only thing that has an update to 10.2.105, and we're going to do that. All of our updates are now complete. The UniFi network application, the UDM Pro Max OS, as well as all of our devices. The one thing that we're going to do first before creating networks, we're going to turn on zone-based firewall. So if we looked over here for object-oriented networking, it says zone-based firewall required. So we're going to click on traffic and firewall rules, and we're going to go to upgrade to the new zone-based firewall, and we'll click to upgrade. This will take a backup of your current config. We haven't done anything yet, so we're just going to press upgrade. We're going to get into the security settings and firewall settings later on, but the next thing we need to do, we need to create our network. So we'll go over to networks. I'm going to click on create new. Looking back at our topology, we still need to create our guest IoT cameras and our staff. So we'll start with our guest network. I'm going to give it a name of guest. The router that we're going to be using for this is the Mactelecom PM. That's my Pro Max. We're not going to be using any layer 3 switching. Then we have zones. The zone that this network is placed in, networks can only be associated with a single zone. View zones in the firewall. For now, all of them are just going to be in our internal zone. But for this one, it's going to be in hotspot as it's our guest. This zone is used for guests on untrusted networks that have restricted access. If the landing page is enabled in the hotspot setting, guests are also restricted for authentication. So that's exactly what we want. In our Wi-Fi settings, when we do it for our guest, we're also going to turn on guest isolation. Scrolling down to our IPv4 settings, we could see auto scale network. We're going to uncheck that, and then we're going to get it an IP address, 192.168.20.1 with a net mask of 24. Then we're going to scroll down to the bottom. I'm going to give it a VLAN ID of 20. I like to match my third octet in the IP address to my VLAN ID. Now we're going to click on manual, and there's really not much more we need to do for this. Since it's already in a hotspot zone, it will create us some firewall rules. We don't need to isolate it as it's already isolated. So let's press create. Now the next network we're going to be creating is our IoT network. So we'll create new and we'll name it IoT. This network is going to fall under our internal, and we're going to go down. We're going to uncheck our auto scale network, and I'm going to do 192.168.30.1. We'll scroll down again and we'll give it a VLAN ID of 30. Now there's a bunch of different ways that we could do firewall rules within Ubiquiti. If you want to do it the easy way, we have IoT. We don't want that to talk to anything. So we could go ahead and we could isolate this network. So this won't allow it to talk to guest. It won't allow it to talk to default. And that's what I'm going to do. We're also going to want to make sure that MDNS is turned on for casting purposes, and I'll press create. I went ahead and I created the camera network and the staff network. Let's click on the staff network. You can see the IP address that I gave it as well as the VLAN ID. I left everything else on auto so that we could do some firewall rules. We're not going to want the staff to communicate with the guest or the IoT, camera, or the default network. So we'll touch on that when we look at our zone-based firewall. Now that the networks are created, we need to create Wi-Fi networks to associate them. So we'll be creating Wi-Fi networks for the guest, IoT, camera, and the staff. We'll click over on Wi-Fi and we'll click create new. The first one that we're going to create is the guest network. I'll put a name of guest and a password of 1234. We don't actually use a guest network here. So I'm going to type in the name, and then I'm going to put that password of test1234. And this is where we need to select the network that it associates it with. We don't want it to be on the native network. We want it to be on the guest, and we'll click that off. Once we click off the guest, it has a captive portal because the type that we put it as was the hotspot. Once we click on guest, you could see that it transforms it to be a hotspot type, and it's a captive portal. A couple things to be aware of when you're using the type of hotspot is it will put it to an open security protocol. We're not going to want that. We want it to be on WPA2/WPA3, and we're going to give it a password of test1234. I'm going to apply those changes, but also by default, the landing page is enabled. So we're going to go over to the hotspot portal, and we're going to scroll down and we're going to go to show landing page. We don't want this at all, so we're going to turn that off and we're going to save. So now all we should need to do to get into the guest network is type in that password, and we won't see a landing screen. The next network that we're going to be doing is our IoT network, and I named that Dolores. and I'm going to put a password in for it. Our network is going to be the IoT network, and then we have a couple different things that we could do. We could do broadcasting APs, which I'm going to do it on all as I only have 2 APs. We have the application, so we have standard, we have hotspot, or we have IoT. This is my IoT network, but I still want to leverage the 6 gigahertz. Changing this over to the application of IoT, it will just bring up the 2.4 gigahertz. I myself haven't had any issues with any IoT devices connecting when we have all 3 bands going, so I'm going to leave it at that for now. But if you are having issues, you may want to change it over to IoT. Everything else we're going to leave at default, and we're going to press create. I went ahead and I created 2 other Wi-Fi networks for the camera and the staff, as it's the exact same thing that we would do. You could see the network is staff, and if you want to get into more of the advanced settings, you can. We have roaming assistance. You could have it on WPA2, WPA3, or you could do enterprise or just WPA3. If you put it on WAP3, legacy or IoT devices may have troubles connecting to it. So this is a happy medium, doing WPA2 and WPA3. Now going down at the bottom, there are a couple different things that we could do within our unified network for our Wi-Fi networks. We have our channel plan, so we could click on a channel to exclude it from use. I'm going to leave everything at default. You can see here that these red ones, these are all excluded because in our 2.4, we only want to use channel 1, 6, and 11 as they're non-overlapping. You'd see we have our 5 gigahertz and then we have a huge range for our 6 gigahertz. Also under the Wi-Fi section, we have default Wi-Fi speed. So we have maximum speed, conservative, and then we have custom. So for our conservative, we have our channel width at 20 megahertz for the 2.4. You never want to put this on 40, ever, ever, ever. That's a major thing, and it will cause you tons of interference if you do. The 5 gigahertz on conservative is on 40, and the 6 gigahertz is at 160. This is typically what I use. So I'll push this out to a business. On the 6 gigahertz, the only thing that I would actually change is I'd push it up to 320 as we have so much space to work with on the 6 gigahertz. So this is typical of what I push out when we're going to do a client install. If you want to see more speeds, a lot of people do it. They'll push their 5 gigahertz to 80, but I prefer stability over speed. Speed doesn't really matter to me. I'm still getting great speeds when it's at 40 megahertz. Channel AI we'll look at when we're doing some Wi-Fi optimization, and same with these other things. Wireless meshing, if you don't have a wireless meshing device, say you have a access point that you're plugging into a PoE injector, but you have no physical cable going back to your switch, that is what wireless meshing is for. If you don't need that, turn it off and it will save you some airtime. I'm going to go ahead and I'm going to apply these changes. As we're on Wi-Fi, we should just continue talking about it. So what I went over to is this air view mode, and we have our radios. We can see all of our radios here. So we have my U7 Pro XG wall on the 2.4, 5, and 6, and then we have my E7 on the same bands. We also have this channel AI view. But if we want to change anything with these access points, you could click on the access point itself and it will bring it up. This is just for the 2.4. But if we go ahead and we select them all, it's going to bring up everything. So we could push out bulk updates. Our channel width for the 2.4, I already said, never touch that, leave it at 20, but we can change the channel that it's sitting at. So if you want to do auto channel or if you want to do manual, you could do that. Also with our transmit power, leaving it on auto, I believe that sets it to high. So you may want to put it to medium if you have a lot of access points. You'd also see this key metrics down here, and this is going to show us some statistics. So we could see what's being used, and we could also see our interference, which is at 21% currently. So that's not the best. My access points haven't really been active because I've been doing this video and I've been taking down the Wi-Fi SSIDs. But this is a nice graph to see so that you could do some troubleshooting. Now we could also do the channel AI view. What this is going to do, it's going to allow us to optimize our 2.4, our 5 gigahertz, and our 6 gigahertz. You'd see with the 5 gigahertz, they're on the same channel, and we don't want that. So I'm going to click optimize. Now that we did that optimizations, it says based on current interference and usage, channel AI recommends applying the following optimizations. So it's going to move the U7 Pro XG to channel 100 and the E7 to 56. So I'm going to apply that. And then we're going to do the same on the 2.4, which it may not come up with anything. It may be great where it is, or it could switch one of them to channel 6. Now it says channel AI optimization, no improvements. I only have the 2 APs, so nothing is overlapping in my house, but you need to take in consideration your neighboring APs. So we'll do the same on our 6 gigahertz, and we'll probably see no improvements here. And there's no improvements on the 6 gigahertz either, so that's great. We also have this roaming, so it's going to show us what our devices are doing. This iPhone, it was roaming from the U7 Pro XG to the E7. The result was successful, and it went from minus 77 dBm to minus 70. I probably should put another access point in my house on my top floor because there's nothing there yet. But we could also take a look at this roaming visual. There won't be too much in my roaming visual. Like I said, I only have the 2 APs, but if you had 40 APs, this would be nice to be able to see. We could also take a look at a bunch of our different devices and check them off on the device list, but a lot of these haven't been connected yet. We have the connectivity visual, which is going to tell us if everything is 100%, if it's associating and it's authenticating to the access points, then it's getting DHCP, it's getting DNS, and then it's going out to a server successfully. We also have the environment, which is going to tell us what is currently around us, and this is for the 5 gigahertz. You can see there's some overlap there. On the 2.4, there's a lot of overlap, and these are mostly all my neighboring devices. This Elgato key light is probably something actually in this office that is broadcasting. This is over a day time range, but you could go up to a month or you could do custom. So this is also great for troubleshooting. There's a couple things on the dashboard that we could look at for our Wi-Fi as well. At the bottom, you could see that it says the AP density is good. So I wouldn't really need to add another access point. We have the AP radio TX retries, which is also showing green. And then we have the Wi-Fi connectivity, which is 100%. We could also look at the 2.4 and we could look at the 6 gigahertz. There's a new thing that Ubiquiti introduced, which is this Wi-Fi doctor. So let's go ahead and click on it. And it says Wi-Fi optimization available, recommended optimizations. Optimize 2.4 gigahertz channels for IoT, which I'm not going to do. I already explained why. And then it says 5 gigahertz / 6 gigahertz inter-roaming enhancement. If I click to apply, this would push my IoT to the 2.4 only gigahertz. And I don't want to do that, but that's something that you may want to look into. We've now seen how to create networks and Wi-Fi networks, and when we connect to a Wi-Fi network, we would get on a specific subnet. But how do you do that for physical cabling? Well, that's the next section that we're going to go into. So I have an ECS 48 PoE. By default, all these ports are on the default network, so 192.168.10.102. So if I click on it, we're going to want to go over to Port Manager. There's a couple things that you could see here. You could see our link speed. So the purple one is 25 gig, the green is 1 gig, the blue is 2.5, and this amber one is fast Ethernet. We could also see what is connected to this switch. I'm going to go ahead and I'm going to click on the Port Manager. Within the Port Manager, it shows us all of the ports, and we could turn off the port diagram if we don't want that, and then we could select individual devices. But I actually really like the port diagram. That's what I use the most. We can see that I have a G6 180 connected, I have a G6 entry, and other devices. All of these devices right now are getting 192.168.10.1 network, and we don't want that. Some of it we're going to want to change over. So let's start with changing our cameras over. If you click multiple of them, it's still only going to take one at a time. So you're going to have to go down in this list. We know that we have 17, we have 13. I'm going to scroll down and see if we have anything else on here. We have my smart PoE chime, which is a part of my camera network. We have my G3 Flex. We have another G3 Flex right here. And that looks like that's all because the other ones are on my other switch. So what we're going to want to do with this, we need the port to be active because we want it to be getting some data. And we need to change the native VLAN and network. You could see that it's currently on the default network. I'm going to click this drop-down menu and I'm going to select camera. From here, we have our tagged VLAN management. We want this to act as an access port and only the camera network to be able to go over it. So I'm going to click on block all, and then we're going to apply those changes. Now these cameras won't get a new IP right away. So if you want it to go faster, you could always click on the port and then you could power cycle the camera. Once it's done rebooting, it will get an IP from our camera network. I have another device on here, which is an IoT device. So I'm going to do the exact same thing. I'm going to click on IoT as our network and we're going to go block all, and I'm going to apply those changes. Now I do have my computer right here on port 33, and I've already moved this over to the staff network so that we could do some testing when we do firewall rules. The only thing that you want to leave on allow all is between our switches. So from switch to switch to our UDM, and then our switch to our access points. You want the profile to look like this: native VLAN default, and then allow all, so that all of our subnets could go to those switches and to those access points. If you only put on the guest network, say, on this switch, it will only get the guest network. If you do that for an access point, it will only be able to connect to the guest Wi-Fi network. You won't be able to connect to the IoT or the staff. So that's one major thing that we do in troubleshooting. A lot of the times somebody will call me and say, why isn't my IoT network working? Well, they've locked it down to only be on a different native VLAN, which you don't want. So keep it like this, which people typically refer to as a trunk port. There are some other things that we could look at in this port diagram. So we have anomaly. What an anomaly is, if there's something physically happening with this port. So say you have a bad cable, it might shoot out an anomaly. You usually want to see these at 0. If they're at anything other than 0, you might have a cable issue or you could have a device issue. You could see the same thing for the SFPs. Right now, I don't have any anomalies. Something else that's new within Port Manager is this time machine. So if we turn time machine on, this is going to give us a live view of what was connected to these ports previously. So we could look at the last 24 hours to see what's connected or what's disconnected, which could be useful in troubleshooting. We'd also filter it down to our different VLANs. So we have our native VLAN, our staff. We also have in use, we have not connected. Then we have PoE, we have none or PoE++. And then we have all of our different link speeds. We now know how to set our physical connections with the specific VLAN or a network. We're just going to go down this list. So we have our internet and then we have our VPN. So with our internet, I have 2 internet connections right now, Bell and Rogers. If we had a third internet connection, we could create new. And I believe depending on the device you have or the cloud gateway, you could do up to 8. I'm going to go ahead and I'm going to click on Bell. We could give the Bell a name. We could specify which port we want it to be on. This is on my port 10, which is my SFP plus. We'd say the expected speeds, which are 3000 by 3000. And then we have manual. So if your ISP requires you to do a VLAN ID, MAC cloning, or you want to do smart queues, you could do that. UPnP, I recommend never putting on. We also have our IPv4 configuration. So DHCP, static, PPPoE, which I'm just using my DHCP. And we do have our auto DNS servers. Leaving it on auto DNS, this is going to use your ISP's DNS. So I'm going to put this to 1.1.1.1 and 8.8.8.8. So we have Cloudflare and we have Google. I'm not even going to touch on IPv6 because I don't use that. So we're going to leave that disabled and we're going to apply the changes. Now we have different WAN modes and there are 2 different WAN modes. We have failover only and we have load balancing. I use failover only and that's pretty typical for all of my installs. Rarely ever use load balancing. With load balancing, you want to make sure that both of your ISP speeds are the exact same. This next section is for our VPNs to remotely access our network, or you could do site to site. I won't actually be showing site to site in this. We'll just do teleport, VPN server, and VPN client. Probably the easiest one is to do teleport. All we need to do is generate a new guest invite. And then all we do is copy that invite. I'm going to go ahead and I'm going to open up here on screen. Now you would send this to the user and they could scan the QR code or they could download the Wi-Fi Man app on their computer. So I'll open up the Wi-Fi Man app and I'll show you how that works. I have the Wi-Fi Man application opened up on my desktop. And if you have a Ubiquiti account, you could sign in and any VPN that you could get into, you'll be able to see here. But I'm going to go ahead and I'm going to add new. So this would be like if you're trying to add a staff into your network and all we need to do is copy and paste that link into here and press connect. To show you this VPN will work, I put my computer on my iPhone hotspot and we're going to try to ping right now 192.168.10.102, which we won't be able to because we're not connected. So I'll go ping 192.168.10.102 and you could see that we're not getting any replies back. So I'm going to bring open Wi-Fi Man desktop and we're going to press connect. We're now connected to the VPN and I'll bring up the command prompt again. I'll press up and we should be able to hit this and we can. One issue with the VPNs, because our default security posture has allow all, is we could actually access literally everything and all of our different subnets. So what I'm going to do, I'm going to end up doing firewall rules to block that off and only allow the VPN to communicate with my NAS. But let's go ahead and check out the other types of VPNs. The next VPN type is our VPN servers, and I'm going to click on Create New. Here we're going to have a couple different options. So we have WireGuard, OpenVPN, or we have L2TP. I'm only going to do one of these options, but you could use whatever you want. You probably shouldn't use L2TP anymore. We're going to go with WireGuard. We could see the name is a WireGuard Server 1, and I'm going to scroll down. You'd see the server address, which is grabbing my public IP, and it says listen on all IPs or selected addresses. If I scroll down even more, it will say add client. But first, what we're going to do, we're going to go to advanced, and we could select which IP subnet that we want it to be on. It's showing that it's going to be on 192.168.4.1 with a net mask of 24. And we also have our IPv6, which I'm going to turn off. We have auto DNS servers. I'm going to choose, again, Cloudflare and Google 1.1.1.1. 8.8.8.8. If you have your own internal DNS, you could set it as that. I'm going to go ahead and I'm going to click Add Client. From Add Client, I'm going to give it a name. I'll call it Cody. And then we have our configuration file that we need to download, or you could scan this QR code. It will also give us an IP for the interface. So 192.168.4.2, that's what I'll be getting for this WireGuard client. So let's go ahead and we'll download this config file. Once that's downloaded, we're going to press save, and then I'm going to go to create. With the WireGuard configuration now done, you need to have a WireGuard client, so you'd have to go download that. We're going to add a tunnel. I'm going to click on add tunnel. Then we're going to go over to my downloads folder, and this is the WireGuard server for Kodi. I'm going to click on it and we're going to press open. Now we can see that the status is currently inactive, and once I press activate, this will connect us to that WireGuard VPN. But I'm going to show you again that I can't reach that switch. Actually, I'm going to go up and I'm going to press -T because it will start doing ping replies once we activate. So let's go ahead. We're going to click on activate. The WireGuard tunnel is now activated, and you could see that we're able to get to this switch. WireGuard is probably one of the faster VPNs over OpenVPN. If you're using UniFi Teleport, that is based off WireGuard, or if you're using Identity, which we're not going to touch on in this video, that also use WireGuard VPN. The next VPN type that we're going to look at is our VPN client, and this would be if you wanted to route traffic over something like Nord or maybe Mullvad VPN. We're going to click on Create New, and there's two different types that you could do. You do WireGuard or you could do OpenVPN. I'll be using Nord, so we'll use OpenVPN. You could give it a name, and we need to upload a configuration file. So let me bring Nord over to show you guys how this works. Over on NordVPN, we could see different servers, and this config file we need to download. You'll want to select the location where you want this VPN to go over. I'm going to scroll down and we're going to go through the United States. I am Canadian. So I'm just going to grab this first one and we'll get configuration setup. And we're going to do OpenVPN and we're going to do UDP. Something else that you're going to need is this service credential. So I'm going to verify my email and then I'm going to grab that service credential. And once we verify the service credentials, we could see we have a username and we have a password, which will need both of these. So let's go back to the UDM and we're going to upload that configuration file that we downloaded. With the configuration now uploaded, we have a device wizard, which we could tell which devices will go through this NordVPN. You could also do that in our objects, but I'm just going to do it right now. We're going to click on networks, and I did create a new network, so we're going to select it. I just called it Nord, and we'll press save. Now, we also have a content wizard, which we could do off domain, IP, or region. What I would want for this is all my traffic to go over this NordVPN, and we also have the kill switch. So what the kill switch will do, it will prevent the client device from connecting to the internet if the VPN connection drops. Now we need to go back to NordVPN and we need to get that username and we need to get the password. Once we have the username and password in place, I'm going to press create. The OpenVPN client for NordVPN is now active, as you can see, and the server address is 107.173.69.227. Anybody connected to that network that I created that was called Nord would be routing through this tunnel. The next section that we're going to look at is our CyberSecure. At the top, we could see protection, content filtering, and then traffic logging. We also see upgrade to CyberSecure enhanced by Proofpoint in Cloudflare. Clicking on that, it's going to tell us everything it gives us. So it's $139 a year. That is Canadian for the UDM Pro Max. It detects and blocks advanced threats. We get up to 55,000 signatures, so on and so forth. We're not going to activate that right now. We're going to look at simple app blocking next. We'll create new, and what I'm going to block is we're going to block Facebook. So I'll give it a name of block Facebook. We could either do this per device level, or we could do it for a full network. I'm going to do this on a network, and we're going to do it on the staff network, and we'll press save. Now we have our app, so we could either do specific or we could do a category. Let's look at the categories just so you could see them. But they do have quite a few categories. We have social media in there. We have peer-to-peer networks. We have online games. We're just going to do specific, and I'm going to select and we'll type in Facebook. So now with Facebook and Facebook Games and Facebook Messenger, we're going to save that and we're going to have it always on. A schedule may be good with somebody who has kids, and then we're going to press add. Now you can see that simple app block right there, but you could also do this in objects. Like I said, there's more than one way to do things within the UniFi network application. The next thing, we have region blocking. It says block or allow connections to and from certain regions. I'll check that off, and you could block in both directions, outgoing or incoming. You could also allow. So if you want to do a blanket block, like block a ton of different countries and only allow a few in, you would put in allow. So say we want to just allow United States and Canada, well, that would block out the rest of the world. So if we want to just do a few countries, I'm going to select block. We'll do both directions. I'm just going to say Russia and China, as I've done that in previous videos. Now that saved, traffic in both directions, incoming or outgoing, will be blocked for those different regions. We have encrypted DNS, and looking at that ensures privacy and security on DNS traffic by encrypting it using DNS over HTTPS. Use one of the predefined DOH servers or manually add a custom server. What I'm going to do, I'm just going to have this on auto. It gives us a warning, enable DNS shield. The DNS servers configured on the WAN will no longer be used, which we did configure Cloudflare and Google, and that's fine with me. I'm going to press enable. By default on auto, it's Cloudflare and Google anyways. The next thing we have is our honeypots. Detects and logs requests made to a specific IP address in order to find malicious clients on the network. So we're going to go ahead and we're going to create this for every network that we have. I'll create new, we'll put it on for our default, and you can see the IP address here. It's always going to take the 192.168.10.2 or the .2 of every network. So if you want to change that, you're going to want to do it ahead. Make sure that you don't have duplicate IPs because that can take down your network. So we'll go ahead and we'll press create. And I'm going to do that for every single network. So we'll do guest. We're going to go ahead. We'll do IoT. We're going to do cameras. And then the last one is going to be our staff network. Scrolling down, we have our identification. Identifies and shows information on the type of devices that are present on the network and traffic sent through the UniFi gateway. You could have this disabled. You could do device in traffic, or you could do traffic only. I always leave it on device in traffic. We have two last things, which is block page, which we're not going to touch on. And then we have intrusion prevention, which is probably the biggest thing within our CyberSecure. We're going to want to have that turned on. I'm having it turned on for all of our networks, but there is a limit to what you could do. I think it's about 10 to 15 networks. Now we have two different types. We have detection mode. So we have notify or notify and block. To me, notify and block makes sense. If it's blocking out something that I actually need to get to, I'll just whitelist it. Under our active detections, you could see that we have a bunch of different toggle switches. I'm going to turn mine fully on. So this one right here, it's 6 out of 7. We're going to select all, and then we're going to do protocol vulnerabilities, 11 out of 12. So we're going to put online games on. So if you do play online games, it doesn't mean that it's going to block your Call of Duty match, but if there's something malicious found, it's going to block that. So what we'll do, we'll apply the changes. If you want to whitelist something, you're going to do it under the detections exclusions. The next thing that we have is our content filter. You could give it a name and you could select the source. So the source could either be a client device or it could be literally a full network. You could do ad blocking on this, and then we could set our different searches. So we have safe search for Google, Bing, and YouTube. We also have filtering for off, enhanced, or basic, which is adult and malicious filters. You have an allow list and you have a block list, and we also have a schedule. If you're paying for the CyberSecure, you're going to have this enhanced filter, which is going to give you a ton more different toggles if you're really looking for great content filtering. We're just going to run through traffic logging. We're not going to enable anything in this video, but we have NetFlow, we have flow logging, we have activity logging, which is syslog. So you could push this off to a syslog server, maybe in a NAS, or you could do it to a SIEM server, and you have your debug logs. We have data retention, SNMP monitoring, and then we have different logging levels, which is set to auto. But if you don't want it set to auto, you could do it manually yourself. We skipped over the high availability section. We'll get there after we do this. We're going to look at the policy engine. In the policy engine, it has the policy table, it has our zones, so our firewall, and it also has the objects. So right now we're looking at our policy table and everything that's been enabled or has been configured. So you can see at the top, we have an OpenVPN client. We have Masquerade NAT. So this is for all of our networks to go out to the internet. And we have DHCP. On the side, we could filter things out. So you could see the policy types. If you just want to look at the firewall rules, you could see that there. You see UniFi Talk, it's put in some different IPs because I have enabled UniFi Talk within my UDM Pro Max. We could also look at policy-based routes, which is the route that I created to go out towards Nord. You could create new policies by clicking on Create New Policy. And here you could specify what you want to do. Do you want to create a firewall rule? Do you want to route? Do you want to do quality of service, NAT, DNS, ACLs, or port forwarding? We're not going to do any of that. We'll do that within our objects. So the next thing that we're going to look at is our firewalls. In this video, I'm just going to be doing our basic firewall rules. I know a lot of people have questions about this as well as the different zones. So let me know in the comments below what you want to see configured, and I am going to do a follow-up video with those comments showing you how to configure it. At the top of this page, it tells us how the zone-based firewall works. Zones simplify firewall management by grouping network areas, allowing broader policies instead of numerous individual rules. This reduces complexity, enhances security, and eases traffic monitoring and management. So if you haven't enabled this yet, I would suggest that you enable it because it does take a backup, but you won't be able to use the objects without having zone-based firewalls. So for our zones right now, I haven't created any zones, but we have internal, which is our networks that we created over here. We have external, which is our WAN connections or our open VPN client. We have the gateway, we have our VPN, we have hotspot, which is for our guest network, and then we have our DMZ. For this, I'm going to create two different zones. So we're going to create a zone, and the first one is going to be called untrusted. Within this zone, we're going to put in any untrusted network. So we're going to select the network interface, and I'm going to say IoT network and save. I'm going to press add entry. A warning is going to come up, move network to zone. Please proceed with caution and view the policies applied to the zone to ensure traffic from devices is not accidentally blocked, and we're going to press proceed. With that new zone created, you could see the untrusted zone and the IoT network is in it, and we could also now see it under our zone matrix. So we see our source, and then we have our destination. So if we look at our untrusted and click under internal, you could see that it isolates this network. So the untrusted network or our IoT won't be able to reach any of our other networks, which is exactly what we want. We don't want this to be able to reach our guests. We don't want it to reach cameras. We don't want it to reach staff or our default network. Now, to be able to do casting and whatnot, say you're on a different network, that's where you're going to want to make sure that you have MDNS enabled within those networks. So you could see here the gateway MDNS proxy is set to auto, but you could select custom and specify the networks. So if you want to have cameras to be able to cast to something on IoT, you need to make sure that those are both enabled. I'm also going to create a zone that's called trusted. Within this zone, I could put the default network in there, but for this video, I'm just going to put the staff network. We're going to save, and then we're going to add the entry in, and we're going to proceed. You'd see that it has added it here, the trusted network, and this is also blocked from different traffic. There's two things that our staff network needs to be able to access that are on different networks, which we can't reach right now. I'm going to bring open a command prompt. We're going to verify that I'm on the staff network by going ipconfig, and you can see we're on the 50 network. We need to be able to get to a printer that is on the IoT network, so we'll ping it 192.168.30.191, and we aren't able to get there. The other thing we need to access is my NAS, and that's on the default network at 10.178, and we also can't get there. So to be able to access this, we need to create a policy for that trusted zone. We're going to have to create two different policies, one for the printer and one for the NAS. So let's go ahead, we'll create policy. We'll say staff to printer, and the source zone is going to be our trusted, and the action is going to be allowed, and the destination, since the IoT is in our untrusted zone, that's what we're going to do. We're not going to say that it could go everywhere. It could go to a specific IP, which is going to be 192.168.30.191. We also want to have auto allow return traffic. Creates a built-in policy for the opposite zone pair to automatically allow the return traffic. If disabled, return traffic must be manually allowed. And that's all we're going to do, and we're going to add this policy. With that policy now created, we could see it here. Staff to printer, the action is allow. We have both IP versions, and then we have our source of trusted going over to our untrusted at this IP address. The next one we need to create a policy and say staff to NAS. The source zone is going to be our trusted zone. We're going to allow, and we're also going to go ahead and we're going to bring this into the internal zone. That is where my NAS is sitting, and we're going to allow auto return traffic. Scrolling down, we're going to go and give it an IP address because we don't want it to get to anything else. So we'll give it an IP of 192.168.10.178, and then I'm going to add that policy. I'm still sitting in that staff network, and let's go ahead and we're going to try to ping the printer. So 192.168.30.191, and we're able to hit the printer. We're going to do the same with the NAS. So we'll do 10.178, and we're able to hit that NAS. But if we go and we try to go and hit a switch, say this switch right here, the ECS switch, we're going to ping 192.168.10.102. We don't have access to that, which is exactly what we want. But what we still do have access to, if we ping 192.168.10.1, we still have access to all of the gateway IPs, and we don't want that. We don't ever want any of the networks to be able to hit a login page of our UDM. So that's what we're going to do in the next firewall rule. We're going to have to create 3 different policies for each one of the zones that we don't want them to be able to reach our login page or SSH for our UDM Pro Max. So the one zone will be internal, and then untrusted and our trusted network. So I'm going to scroll down and we're going to go ahead and we're going to create a policy. The name I'm going to give this, it will be internal, no access to gateway, HTTP, and SSH. So the source zone is going to be internal and it's going to be any. We're going to block, and this time the destination zone is going to be gateway, but we don't want to do the full gateway. If you do that, you won't have internet access. So we only want to do a couple ports. So the ports that we're going to do, we're going to specify a list. We're going to create a new list, and I'm going to call this HTTP, HTTPS, and SSH. The first port that we're going to put in is port 80. Then we're going to put in port 443. And then we're going to do port 22. We're going to create that, and then that's all that we need to do. I'm going to add this policy. Now we're going to create a new policy, and we're going to say block untrusted to gateway. So this is the exact same thing. It's just a different name. Our source zone is going to be our untrusted. This time it's going to be block again. Our destination zone is going to be our gateway, and then we're going to do a list. We don't need to write out that list again because it's already saved, and then we're going to add the policy. I'm going to create another policy, and this is going to be for our trusted. So block trusted to gateways. This is the exact same thing that we need to do. Our zone is going to be trusted. It's going to be blocked. Our destination zone will be gateway, and then the ports will be that list of HTTP, HTTPS, and SSH, and we'll add the policy, and then we'll proceed. These rules won't block out the ping request. I could go ahead and I could still hit this. I am still sitting on the staff network, so let's just verify ipconfig, and I am on the 50. But if we open up a web page and we go 192.168.10.1, we shouldn't be able to hit that page. It will time out. And if we try to hit our own 192.168.50.1, we're not able to get there either. If we had SSH turned on our UDM Pro Max, we wouldn't be able to hit it from this network as well. If you want to block out ping, you could do that, or ICMP messages. It is very useful for troubleshooting, but I'll show you how to do that. We'll create a policy and we'll just say block ICMP to gateways. And this will just be for our staff or our trusted network. So the source zone will be trusted. And then the destination will again be our gateways. We're not going to do anything with the ports here, but we'll go IP version and we'll go IPv4. We're going to do a protocol and we're going to do custom, and I'm going to type in ICMP, and we're going to select the type, and this type is going to be any, and I'm going to press add, and we're going to proceed with that. So we're going to give that a second, and then I'm going to hit the up arrow, and we shouldn't be able to hit the gateway IPs. So you can see that one request went through. That was, well, it was still writing the firewall rule, and now the request is timing out. Let's go ahead, and I'm trying to hit my own IP, so 50.1, and we can't do that either. Like I said, it is useful for troubleshooting, but on a guest network, you never want people to be able to hit this. The last firewall rule that we're going to do is for our VPN. We could see our VPN is allowed to talk to internal, and that could talk to everything internally. If we go to the side, untrusted and trusted network, we can't get anywhere there. But if I bring up a command prompt right now, I'm able to hit my ECS switch, and I am connected to that VPN. So 192.168.10.102. You'd see I could hit that, and we don't want that. The only thing we want our VPN users to connect to is to our NAS. So let's go ahead and we're going to create a policy. So we're going to click on create policy. I'm going to say block VPN to internal network or internal zone. The source zone will be our VPN and the action will be to block. The destination will be our internal zone, and that's all we need to do. I'll add that policy and we're going to proceed. Bringing up that command prompt again, I'm going to hit up and then -T. We're still able to hit the ECS switch, but this will eventually drop out here in a second. As you can see, we can't hit that switch any longer. And if we try to hit my NAS, we shouldn't be able to do that either. So 10.178, and we can't hit that. Let's see if we could hit the .1 though. So we can still hit the gateway. So there's a couple more rules that we need to do. The first rule, we need to allow the VPN users over to the NAS. So let's do that. We'll create the policy and we'll say VPN to NAS. Source zone will be VPN. The action will be to allow internal zone and then an IP address of 192.168.10.178. And then we're going to add that policy in. Again, we don't want our VPN users to be able to go to our UDM page, and we don't want them to do ICMP. So we create new, we'll say block VPN to gateways. Source zone will be VPN, action will be to block, destination zone will be gateway, and then we'll scroll down, we'll go to this list, and then we're going to block all these ports and we're going to add the policy. The next one we need to create, we're going to say block VPN ICMP to gateways. Source zone will be our VPN. It will be an action of block, and this will be also our gateways. But we're going to scroll down this time. We're going to select IP version 4, and then we're going to do the custom protocol of ICMP. And then we're going to select any, and we're going to add that policy. Now let's go ahead and we're going to bring open a command prompt, and I'm going to ping 192.168.10.1, and those ICMP messages aren't going through. But shouldn't we be able to get to the NAS since we created that rule? So we're going to try it out. So we have 192.168.10.178, and we're not able to hit that. And there's a reason for that. So let's go -T, and we'll go back to our rules. The firewall rules go in top-down order. You could see block VPN to internal zone. So this would never go through. What we need to do, we need to reorder this and drag and drop the VPN to NAS, and then we need to press done. I'm going to bring open that command prompt, and we should be able to see those ping requests going through shortly, and we'll be able to access my UNAS 2. As you can see, it didn't take too long, and we are able to access my UNAS 2. So that was the basic firewall rules within our zone-based firewall. Like I said, we're not going to be covering everything here because every business is different as well as every home. Leave a comment down below what you would like to see. The next thing that we're going to take a look at is our objects. Objects is relatively new within our UniFi network application, and I use it quite a bit for policy-based routing as well as quality of service. At the top, it will give you a description of what it is. Object-oriented networking, an intuitive experience for power users. Firewall rules and access lists automatically created by UniFi full stack working together, and it shows you how it works. We have our object, secure, route, quality service, schedule, and it creates a rule, and it puts it in the policy table. We could do this specifically just for a device, or we could do it for a full network, and I'm going to do it for a network. We already have a policy-based route set out for the NordVPN, but say we wanted our IoT network to go over that NordVPN route as well. I'm going to call that IoT to NordVPN. What we're going to do here, we're going to go over to our route for our policy-based route, and we're going to check that off. We could either specify all traffic, domain, IP, or region. I'm going to say all traffic within this IoT network is going to go over our OpenVPN client, which is NordVPN, and we're going to have the kill switch on. Say you didn't want it going over NordVPN, but we do have that backup internet, and you want it to go over that. That's where we could say which internet it goes over. Something else that's useful would be our quality of service. So we could say QoS on VoIP and video. We could select which devices or networks that we want this to do. So we'll say default, we're also going to want it on staff. I'm going to uncheck the route, but we're going to go over to quality of service. Now we could say all traffic, we could specify an application because we probably don't want all of our traffic to be a part of this QoS prioritization. So I'm going to select app, and the first one I'm going to do is SIP. So SIP should cover most of the VoIP protocols. We could also do Microsoft Teams. We could do Zoom. And we could do Google Meets. Now there's a couple things that we could do. We could say that interfaces and VPN tunnels, it will go over all of our WANs, or we could specify which one, and we could either limit, prioritize, or we could do both. I'm going to prioritize this traffic and have it on always. So now when we have a SIP call or a VoIP call or a video conference call, this traffic is going to be prioritized above everything else. Let's take a look at high availability. We're not going to set up shadow mode in this video. I'm going to do a dedicated video on that, as it does take quite a while. But with shadow mode, what will happen is if your primary fails, it will automatically fail over to your backup UDM Pro Max or your UDM Pro or UDM SE, whatever you're using. You just need to make sure that both of the consoles are exactly the same. They do have MC lag, which we will take a look at as well in a different video, and they will have stacking. Their stack switches still aren't out yet. But this new thing that just came in within the UniFi network application, which is device supervisors. This is really, really cool. At the top, we're going to see a little diagram of what it does. So we have supervised devices, which is UniFi devices. We have the device supervisor, so heartbeat monitoring, and then we have our different power source. So either a PoE switch or a PDU for automatic recovery. It says continuously monitors device heartbeat and safely power cycles the device via PoE switches or UniFi PDUs if it becomes unresponsive for a prolonged period. I'm going to go ahead and I'm going to click to get started. Here it's showing me all of the qualified UniFi devices that I could do for this device supervision, and I'm just going to go and we're going to supervise all of those devices. So if, say, my AI bullet becomes unresponsive, it's going to automatically power cycle the device, and that may or may not bring it back up, which is really cool to see. I do like that they have this. You could always go ahead and you can manage and take out any of the devices, or you could stop the supervision altogether. We're getting near the end of the video, but there's a few more things that we'll take a look at. So we have our control plane and we have updates. So updates is where we're going to do our UniFi OS update, as well as every single application that we're running on our console. We also have backups. So with our system backups, when it's automatic, this is going to push out to the cloud to account.ui.com. If you don't want it pushing out to the cloud, you could stop that and you could just download it manually. Then we have our storage. So you could see I do have some storage in here. This will be things like system logs and also voicemails for our UniFi talk. If you're using your console for UniFi Protect, that will be used with the storage as well. Now under console, this is where we could do a bunch of different things. We could give our console a name. We could do the location. We could do the LCD screen, email services, analytics, and improvements. We could download a support file. So if you ever have something wrong with it, you need to get the support file out to a Ubiquiti employee or another consultant, you could do that. We have our certificates, and then we have remote access. So with remote access turned on, we could go to our site manager, unifi.ui.com, anywhere in the world, and we could manage our different UniFi consoles. Then we have direct remote connection, which I don't recommend turning on. And if you ever have to turn SSH on to get into the command line, you could do it here. We also have all of our controls. We had restart, shutdown, transfer ownership. So I usually will do a customer's build out, and then we'll transfer the ownership to that person. We will factory reset about this console, and then we have our compliance. The last thing that we have within our control plane is our push notifications, and this is how you want to get notified. So we have our critical, we have updates, we have admin activities, and we could do it either by the bell icon, which would push it out directly to the app on our phone, or you could push it out to your emails. With saying that, we have something called Alarm Manager. So with Alarm Manager, you could create your custom alarm. So if you want to create a new alarm, we have all these different types that we could create, which you could push out to either all admins, or you could do a webhook, or you could do power, which would power cycle an outlet or turn off an outlet or turn on an outlet, and it depends if you have a PDU device. We also have our insights, which is going to show us all of our traffic flows. So you could see where Mactelecom's been going from and to, so that's my computer. Same with my Samsung device. So this is good to troubleshoot, and you could see your security. So we have suspicious and we have concerning. You'd see that for 1 hour, 1 day, or 1 week. You'd also look at the flows on the map. You could see that my UDM's been talking to a lot of different places. So we have Canada, we have United States, and some other places in the world. Now we can also go look at our logs. Now within our logs, we could see a ton of different things that we could customize it by the date. And you could see that we have a category. So client devices, we have security, blocked by firewall rule, and we have VPN. We also have client devices, internet and WAN, and a ton of different things that you should go look at, because this is really where you're going to be looking at your security. So if we click on security, this is just going to show a block by firewall rule. But if you did have one of those IDS or IPS alerts come up from your CyberSecure, it would show up here. One last thing about security, you want to disable all the ports that aren't being used, especially in a business. So how you do that, just check off all the ports that are unused, and then all you're going to say is disabled and apply the changes. You'll want to make sure that you remember that though, because if you plug in a device, it won't ever work. And that's going to be my video on the UniFi Network 2026 walkthrough, and there is probably a lot of things that I did miss, as the UniFi Network application is pretty huge. Like I said multiple times today, leave things down in the comments below if you want to see something specific, as I will be doing a follow-up video for this. If you like this video, hit the thumbs up button. If you're new here, please subscribe and hit the bell icon. All right, thanks.